So far, we've taken a look at what happens if we add or subtract a number to the formula for a parent function. Now we're going to switch our focus to what happens if we multiply by a number. Multiplying by a fraction, like multiplying by 1/2, is the same as dividing by 2. So we're essentially covering multiplying and dividing by a number. All right, and we're going to start, we're on the part of the worksheet that deals with vertical stretches, shrinks, and flips. The first question here is just reminding us of this particular parent function, the absolute value function. Now, you should be familiar with that so that you know that that's just this, this V-shaped graph where the left side has a slope of -1 and the right side has a slope of 1. So you should be able to sketch that without creating the table of values. I'm going to use the table of values just because I want to keep track of some points to see what happens when I modify the formula for the function. So, of course, the absolute value of any number is that number if it's not a negative number, and just the opposite of that number if it is negative. So I'll go ahead and mark off those points here. So the vertex was at the origin 0, 0. Here's my point 1, 1, 2, 2, -1, 1, and -1, 2. All right, problem 2 asks us to sketch g of x, which is 2 times the absolute value of x. So I want to see what happens when I multiply this formula by 2. Notice I'm taking the absolute value of x first, then I'm modifying it to multiply by 2. So essentially, this was the y value on the parent function that's getting multiplied by 2. So if I do something after I've evaluated the parent function, that's going to affect the y value, so that's going to be a vertical change. Now, if you've got the worksheet, I've got a whole new table of values. I'm going to just go ahead and add on a column to this for 2 times the absolute value. This middle column, then, it just becomes sort of a helper column. This is the y values on the parent function. This is going to give me the new y values. And of course, I'm just doubling them. So 2 times 2 is 4. 2 times 1 is 2. 0 times 2 is still just 0. This will become 2. This will become 4. So the y values are becoming twice as big. Now, if I plot these points, I'm going to be plotting, of course, x, and these are the y values for g of x. So this point is twice as high, so this is 2, 4. This point is twice as high, so it's 1, 2. This point is twice as high, but twice as high as 0 is still 0. This is going to become 1, 2, and this will get moved up to 2, 4. When I connect those dots, I still have a V shape, but I can see that the lines that make the rays, the partial lines that make the left and right sides of the V are steeper. What we've done is we've stretched things by a factor of 2, and that's accomplished by making the y values twice as big. Okay, excellent. So I'm going to have you pause the video to work out problems 3 and 4. Problem 3 was to sketch h of x, which is 1/3 the absolute value of x. So you'll be exploring what happens here if you multiply, but by a number that's smaller than 1. So when we multiplied by 2, the y values got bigger. Multiplying by 1/3, of course, is going to make the y values smaller. And then question 4, you're going to be graphing k of x, which is the opposite of the absolute value of x. Now, if you've got the worksheet, you've got tables of values. What I'm suggesting you do, whether you're using the worksheet or just writing things by yourself, is keep these 2 columns here and just change this 3rd column. So for graphing h of x, you'll make this column be 1/3 absolute value of x. And here you'll make it be the opposite of the absolute value of x. And just see what graphs you get. So go ahead and pause the video, work out those 2 problems, and then tune back in and we'll compare the results. I've got the answers for 3 and 4 up here. What I did is I kept the parent graph up. I erased the graph of 2 times the absolute value of x, which was question 2, just because this graph is starting to get a little bit busy. And there will be some times when we're going to make the choice to just graph things on a new set of axes to avoid things getting too busy. But I kind of like, at least initially, to have things on the same pair of axes so that we really can compare what happens to the points. So this column here was for question 3. That was 1/3 the absolute value of x. So I started with an x value. We took the absolute value, then we multiplied by 1/3. Now what that did is that makes all of the y values 1/3 as big as they were on the parent functions. So I'm getting this blue v. It's still a v, but it's much less steep. We've shrunk things vertically. All of my points have a lower height now. And then in purple, I've got this column. This was for the opposite of the absolute value of x. So I'm really just ignoring this column. We start with x, we take the absolute value, and then we multiply it by -1. Now what that did is that flipped the graph vertically so that instead of having this parent v that opened up, we now have this flipped v that opens down. So the y value of 1 here became a y value of -1. So that's what we call a vertical flip. Notice it's a vertical flip. It's flipping things over the horizontal line, the x-axis, because we go from having something that's up here to down here. So it's a vertical change by flipping over the horizontal axis. Okay, so in general, what we can see is that if I have f of x, and then I say g of x is equal to a times f of x, what's going to happen is if the absolute value of a is bigger than 1, we're going to do a vertical stretch. All of this is vertical because I'm multiplying by a after I evaluate the parent function. If the absolute value of a is less than 1, it's going to be a vertical shrink. And if a is less than 0, if a is negative, it's going to be a vertical flip. Here I was talking about the absolute value. With the examples that we did, we multiplied by 1/3. And before this video, we'd multiplied by 2. Those were positive numbers. If I multiplied by -2, that would actually do 2 things, because -2 is just -1 times 2. So the negative would perform the vertical flip. The absolute value of that being 2 would perform a vertical stretch. So if I had multiplied this by -2 to get -2 times the absolute value of x, I can sort of freehand see what that's going to do. It's going to be flipped and stretched. So it's going to be steeper, but also flipped so that it's opening down. All right, so in the next video, we'll take a look at what happens when we do horizontal stuff. As you might anticipate, that's going to be accomplished by multiplying by things before we plug into the parent function.